Good morning. So I am Punityan. So today I will be taking up a topic that is module 3 support reactions. I think you people know I will be taking up elements of civil engineering and mechanics subjects. Subject. So the subject code is 18 CIV 14. In that particularly I will be taking module 3, that is support reactions. In module 3 there are two topics. One is the support reaction and one more is the analysis of simple trusses. Okay, so today let me take up the first topic, that is support reaction. Support reaction. So first, before taking up the support reaction, I will be explaining you people how the load get transferred in a building from the top to the bottom. So let me assume that I am standing on the floor. Obviously I am standing on the floor. Okay, whatever the load that I am exerting, okay, that will be transferred to the beam. Okay, what is the load that is what is the load that I am applying onto the slab? It is getting transferred to the beam. Okay, from the beam the load is getting transferred to the columns, from the column to the footing, okay, from the footing to the surrounding soil. So here the column is the support, I can say, because the column is the support, because for the column above which the beam and slabs are placed. So column is the support. So that's why we call it as support reaction. Whatever the load that we are applying, so to counteract that particular load, I think you people know the Newton's third law of motion. For every action there is an equal and opposite reaction to maintain the equilibrium of the building. Okay, equilibrium means rest condition. So whatever the load that we apply, so there should be an reaction, so that the both load will get counteract and the system will be in equilibrium. Okay, so support reaction. So first one is the types of supports that we usually come across. So the first one is types of supports. First one is simple support. First one is simple support. What do you mean by a simple support? One of the best example is, let me think that you have taken two concrete cubes. Let me think that you people have taken two concrete cubes on which you people will be placing a plywood sheet. Okay, that I can say that it's a simple support. Okay, so in simple support we are having two types. The first one is the hinged support. Hinged support, and the second one is the roller support. Second one is the roller support. So first I will be taking up the hinged support. So first I will be taking up the hinged support. Observe here. So hinged support can be represented using this particular symbol. Hinged support can be represented using this particular support or this particular support. So any of the support you can use. Okay. In hinge support there will be two reactions. So one is in the vertical direction, that is RV, reaction in vertical direction, and one more is reaction in horizontal direction, that is RH. Okay, here also the same thing, resultant in or reaction in vertical direction, reaction in horizontal direction. Okay, so hinged support, as I already told you people, so it is a support on which you can just rest a particular structure. Okay, I want you people to concentrate on these things. Whenever they have given the hinged support, you need to consider that there will be two reactions, one in the vertical direction and one more in the horizontal direction. So now let me move on with the roller support. So let me move on with the roller support. As the name itself indicate, the rolling action will be there. So first let me write down that. So roller support can be shown in this pattern or it can be shown in this pattern. You can use both. For roller support, always remember there will be only one reaction. There will be only one reaction, that too in vertical direction. Okay, as this is also roller, there will be only one reaction, that too in the vertical direction. This semester, I will not be going deep into the topic. Just whenever you come across hinged support, you just think that there are two reactions. Okay, whenever you come across the roller support, you think that there is only one vertical reaction. Okay, so the next type of support is the fixed support. The next type of support is the fixed support. The next type of support is the fixed support. Okay, so now observe. So now let me go with the fixed support. The second type of support, it is the fixed support. It means that in the simple support, what I told you people, so there will be two supports on which an object is simply resting. But here, so what will happen? For that particular two supports, the member will be interconnected and it is fixed. So I will be showing the diagram. Observe here, the fixed support will be represented like this. Okay, there will be a beam. Okay, here what will happen? There will be three reactions. So reaction in vertical direction, reaction in horizontal direction, and there will be a moment. There will be a moment. So totally how many reactions? So three reactions. So please remember while solving the problem, so this is very important. For a hinged support, you people need to consider two reactions. For roller support, you people need to consider one reaction, that too in the vertical direction. Next, for fixed support, so there will be three reactions, one in horizontal, one in vertical, and one more is a moment. Okay, so please remember this. Now we'll move on with the next type, that is the types of beams. I will be going with now the next topic, that is the types of beams. Let me go with the types of beams. So the first one is simply supported beam. As the name itself indicate, simply supported beams. As the name itself indicate, simply supported beams. So observe here, there will be a beam. Beam is an horizontal member. So there will be two supports. There will be two supports. Okay, so where this beam is just simply supported. So there will be some loading. It might be point load or it might be UDL. I will be explaining the point load and UDL in the next case. So this is called as a simply supported beam, where the beam is simply resting on the two columns. So next, second one is fixed beam. So next one is fixed beam. Observe here. So the two ends of the beams are fixed, where the two ends of the beams are fixed. If I call this as A and this as B, the AB is a beam where the two ends are fixed. Okay, so now the third one is, let me go with the continuous beam. Let me go with the continuous beam. I will be rubbing this. Let me go with the continuous beam. third one is continuous beam. As you people know that, so in a building, okay, so in a building, so you can't only go with a single beam, there will be a combination of beam. Okay, so whenever there are more number of beams beside one another, then I will be calling that particular beam as continuous beam. So observe here. So there will be a support. There will be one more support. This I will be calling it as one span. Okay, so like this, there will be many spans. So this is called as the continuous beam. So this is called as the continuous beam. Here the supports are placed at a frequent interval. So here the supports are placed at a frequent interval, or else I can say that the beam is continuous over many supports. Okay, so this is called as the continuous beam. Next one I will be going with overhanging beam. Overhanging beam. Here what happens is, observe, there will be a beam, okay, the beam is supported only at this junction and this junction, at the ends, so there won't be any supports. So this kind of a beam is called as the overhanging beam, where the ends are not supported. So here the ends are not supported. So this kind of a beam is called as the overhanging beam. So now the last one, it's the cantilever beam. Now the last one, that is the fifth one, so it is the cantilever beam. These are the different types of beams. So cantilever beams. Okay, observe here. I think you people might have seen the balconies in the flats and buildings, right? So what happens there? Observe. Let me think that that's a flat. So there will be a bifurcation. Okay, now let me think that I need to provide a balcony over here. Okay, so that some person comes and stand over here. Adjust with the diagram. Okay, so a person comes and stand over here. So there won't be any support here at the bottom. So this kind of a beam is called as cantilever beam. It means that the cantilever beam is supported only at one end, the other end will be free. Such kind of a beam is called as a cantilever beam. So observe here. So usually for a cantilever beam, one side will always be fixed support. So the other end will be free. The other end will be free. So this kind of a beam is called as a cantilever beam. Okay. So now I will be moving on with the third classification. So the first classification, it was the types of support. The second classification, it was the types of beams. The third classification is the types of loads. So now we'll move on with the next one. It is the types of loads. Next one, it is the types of loads. Okay, so the first one, concentrated load. Concentrated load, or we can also call it as the point load. Observe here, let me consider a beam. Let me consider a beam. Okay, so now if the load is acting exactly at the center, whether it will be acting over here or here, for time being let me assume that it is acting at the center. Don't you think that this load is concentrated at a point? So that's why this kind of a load is called as a concentrated load or point load. Here the load will be concentrated on a single point. So such particular load is called as a point load. Okay, so the next one. The second one is uniformly distributed load. Uniformly distributed load. In short form, we call it as UDL. Okay, so let me consider a beam with a support. Here don't bother about support, whether it is a roller support, hinged support or fixed support, as I am concentrating only on the load. Okay, just I have taken it as a support. Forget about whether it is hinged, roller or fixed. Okay, so now uniformly distributed load, uniformly as the name itself indicate, throughout the beam the load will be same. Throughout the beam the load will be same. And one more thing, the unit for the concentrated load will be, W is the load and the unit is kilonewton. Okay, similarly for this particular kind of a beam, okay, the load will be W but the unit is kilonewton per meter, and obviously this will be the span. Let me consider this as the span. Here also we'll consider this as the span L. Now the important thing is, in civil engineering we have some sign conventions, yes or no? For example, upward direction we consider it as positive, downward direction negative, rightward direction positive, leftward direction negative, and in terms of moment, clockwise moment positive, anti-clockwise moment negative, yes or no? So we know only a point load. If the point load is acting in upward direction, positive, downward negative, leftward negative, rightward positive, yes or no? But here in UDL it is not a point load. I don't know the sign convention other than point load, so first I need to convert this UDL into point load. While solving the problems also, first you need to convert the UDL to point load. So how to convert UDL to point load? The formula to convert UDL to point load is W into L. To convert UDL to point load, UDL to point load, the formula is W into L. So observe here. So what is the unit of W? So as I have told you, W kilonewton per meter. So what is the unit of the span, length, in meter? So the unit M and M get cancelled. So it will be W into L kilonewton. So don't you think that it got converted into the point load? Similarly, we'll go with one more load, that is uniformly varying load. So we'll go with one more load, that is uniformly varying load. Observe here. So the third one, it's uniformly varying load. We call that as UVL, uniformly varying load. Okay, let me consider the same thing, a beam. Okay, as the name itself indicates, uniformly varying. Let me think that the load is in this particular pattern. Okay, so here the loads are uniformly varying. Okay, let me assume that the load is W kilonewton per meter and the span is L meter. Okay, the span is L meter. As I told you people in the starting itself, so in civil engineering, so we have only the point load sign convention. So I need to convert this UVL to point load. How to convert it? So to convert UVL to point load, to convert UVL to point load, we have a formula, that is half into base into height. Okay, so it's half into, what is the base? It's L meter. What is the height? Height is nothing but the load. So it's W kilonewton per meter. So here meter get cancelled. So what you are left out with? WL by 2. WL by 2 kilonewton. So now I have converted this UVL to point load. Okay, but the thing is where it acts. That is very important. Okay, and one more thing, while discussing the UDL, Observe here. So this was W kilonewton per meter, okay, and this I have considered it as L meter span, okay. How to convert this UDL to point load? It's W into L is the formula to convert. After converting this UDL to point load, where that point load acts, I forgot in the forgot telling this. Okay, I forgot telling this particular diagram, so that's why I am doing it again. So here what happens is, so here there will be a support, here there will be a support. As we know, sign convention only for the point load. So if I convert this UDL to point load, the formula is W into L, and where it acts exactly? It acts exactly at the center, W into L, and it's L by 2, L by 2, because it is acting exactly at the center. But now in case of uniformly varying load, it will not exactly at the center. Please remember one thing, from 90-degree side, don't you think that it's a right angle triangle? From 90-degree side, it acts at a distance of B by 3 or L by 3. So from 90-degree side, it acts at a distance of L by 3. Please remember. So now what will happen? Observe here. So now this is a support. So this is also a support. Okay. So from 90-degree side, okay, the point load will act at a distance of L by 3 from 90-degree side. And what will be the value of this point load? It's WL by 2. Total is L. Okay. If this is L by 3, don't you think that this is 2L by 3? So please remember one thing, from 90-degree side for a triangle, the point load will be acting at a distance of L by 3. Away from 90-degree side, it acts at a distance of 2L by 3. Okay. So the same thing, the same UVL, if they give it in other pattern, if the same UVL, if they give it in other pattern, observe here what will happen. So let me think that they have given a beam. Instead, the UVL to be higher in this particular place, I will be taking the UVL higher at this particular junction. Okay. So now what will happen? Same thing, the span is same, L meter. So the load is also same, W kilonewton per meter. So how to convert it? Half into base into height. Final formula is WL by 2. Okay. So now I will be converting this UVL to point load from 90-degree side. Okay. It acts at a distance of WL by 2. It acts at a distance of L by 3 from 90-degree side, and away from 90-degree side, it is 2L by 3. Just observe the difference. If the UVL is higher at this particular junction from 90-degree side, L by 3 will be over here. If the diagram is like this, from 90-degree side, the L by 3 is over here. So these are the basic concepts that I want you people to remember. These are the basic concepts that I want you people to remember. Let me brush up what are all the things that I have done. Okay. So I have discussed 3 classifications in this particular class. The first one, it was the types of supports. Okay. The first one, it was the simple support. In simple support, there were 2 types. One is hinged and one more is roller. In hinged support, you people will always come across 2 reactions. In roller support, you people will come across 1 reaction. Okay. In hinge, vertical and horizontal reaction. In roller support, only vertical reaction. The second type of simple support is the fixed support. Sorry, the second type is fixed support. Okay. Fixed support, 3 reactions will be there. One in the vertical direction, one in the horizontal direction, and one more is the moment. So next we moved on with the next classification, that is the types of beams. We discussed 5 types of beams. One is simply supported beam. The second one is the simply supported beams. The second one is the continuous beam. The third one is the cantilever beam, and the fourth one is the continuous beam. Okay, and one more is the overhanging beams. So these were the 5 beams that we have discussed there. Okay, the next thing we moved on with the types of loading. So there are different types of loading. The first one is the point load. The next one is the uniformly distributed load, and the third one is the uniformly varying load. So in the next class, we'll deal with the other topics. Okay, for as of now, we'll wind up. Thank you.